Hi, today you're going to complete experiment force and motion. Start by filling your name, program, matrix number, and also which group. The website that we're going to use is ophysics.com/f2html. Once you click this link, it's going to bring you to this website here. You check at the value will be the same. Later on, we're going to change the value. We will have a fixed values and also the change value. And we want to compare for task number 1 would be what is the critical value of coefficient of static frictions. We're going to change the highlighted value. After clicking start, at which value going to cause this block start to move. This is the number that we want to identify. When we go to task number 2, this is to find what is the critical value of the angle. The highlighted one, we want to change the angle and then to check at which angle this block going to move. This is the number they want to find. Let's start task number 1. Task number 1 will be starting here, the bold one. We want to fix some of the values here. Starting by initial velocity, the default given is -5. So we change to what number? 0. The second one will be the gravity, 9.8. Okay. The third one will be the mass. We want to choose the block equals to 10 kilogram. The coefficient of static friction, this will be starting by 1. Okay, we'll start from 1. The next one will be coefficient of kinetic friction. We start 0. This one we just ignore. It won't into our calculation. The angle will be 30. Okay, this will be the setup for our first testing. We want to have the coefficient of static friction equals to 1. Okay, 1 here, 1 here. Okay, let us start and see whether the block is going to move down or not. Start. Oh, it's not moving. We're going to pause. So we're going to have the big X to represent 1. Why? Because the block is not moving. Okay, we're going to change the static coefficient into 0.9. Change into 0.9. Let us start. Still not moving. So we're going to have a big X here. Okay, we test 0.8. Let's start. Now it's still not moving. Going to do until the number that you're going to start. Okay, let us try the close the exact number, 0.6, whether it's moving or not. No, it's not moving. Okay, that's 0.5. Start. It's moving. It's moving. Okay, we'll stop it first. We'll stop it first. Okay, this one will be yes. Okay, I'll use the symbol yes. Means that the block going to move in between 0.6 to 0.5. You want to find until 3 decimals when this object is static, still static. Is it 0. maybe 587? We don't know. Go test one by one. Since 0.6 until 0.5, the block going to move. So we can test starting from 0.59. Click start. Still not moving. Okay, 0.59 not moving. How about 0.58? No, still static. 57. Yes, it's moving. Means that this block going to move in between 0.58 until 0.57. You need to find what will be the exact value. It is still static. Is it 0.577? This is your task. Okay, after you get the value is still static, not moving. So in here, maybe it's 0.577. You need to check. Okay, after that, try to prove the last equation here. Is it same or not, equals to 0 or not? So M will be how many kilograms? 10 kilograms. What will be the G? G will be 9.8. What will be the sine theta? Sine theta is 30 degree. They're equivalent to 0.5. Okay, minus. Assume that the static coefficient, the block is still not moving, is 0.577. Where can you get this value? From here. And then M will be 10 kilograms. G will be 9.8. And then cos theta, cos 30 degree will be 0.866. At the end, whether will be 0 or not, or close to 0. Prove it. Then this is the value that the block is starting to move. Okay, let's say 0.577, the block is still static. We start to make the surface become more, more smoother. So it might be 0.576. Let's say, I'm not sure, let's say 0.576. So once you put 0.576, the block start to move. That will be the critical value. The block is moving. Now you want to apply the same calculation, only that want to prove that minus these two will produce a larger than 0 value. So we're still putting the same value here. Okay, I'll copy it. Is it greater than 0 or not? Be careful, it's no longer 0.577. Why? Because our new coefficient static is 0.576. So change to 576. Okay. Prove it whether it is greater than 0 or not. Okay, I'll move to task number 2. Task number 2, open the same website, okay, the same one. Now, instead of changing the coefficient of static here, you want to change the angle here. We're going to set the fixed value. The initial velocity equals to 0. Okay, is equal to 0. No problem. The gravity 9.8, 9.8. Mass 10. Okay. Coefficient of static friction 0.42. Okay. Coefficient of kinetic friction is 0. Okay, no problem. We'll start angle from 0. So we'll change to 0. Press enter. We'll have a flat surface. So flat, a block, we can guess it is not going to move. Anyhow, we're going to test it, and then later on we're going to fill into the table here. We're going to test start by 0. Start, not moving. Okay, it's okay. We increase to 3. 3, press enter. Still not moving. So we're going to have a big X for 3. Okay, let us try 12. We jump to 12. Start. Still not moving. You need to find what is the value until 1 decimal. This block is still static. It's still not moving. And then fill into the box here. Let's say again, the angle will be 22.8 degree. This is the angle that this is the angle that the block is still not moving. we want to prove that at the end, the left expression will equals to 0. So fill inside, the M will be 10 kilogram, G will be 9.8, and then sine, the angle will be 22.8 degree. Okay, and then going to minus, mu SS will be 0.42 here, 0.42. M will be 10 kilograms, G will be 9.8, and then cos theta will be 22.8 degree. Okay, prove this one whether will be 0 or not. Prove it. And let's go to the next part, will be the first value, the angle that the block is starting to move. 22.8 is not stiff enough, so it's still static. We increase just a little bit, one more decimal, that will be 22.9. Yeah, up. So the block is moving. So we're going to fill in 22.9 degree. Then later on, fill inside the left expression here and see whether it's going to be more than 0 or not. Supposingly, it will be greater than 0. Okay, after you finish these two tasks, we're going to move to the discussion. The first discussion is referring to task number 1. Okay, we're going to refer to task number 1. Task number 1 is changing the changing the coefficient of static friction. Okay, if the mass of the object reduces, 10 kilograms become 2 kilograms. Will we have a different coefficient static value here? Proof by using this formula. Okay, later on, fill inside this formula. Fill inside this formula and then start to expand it. How to expand? Because the formula can be expanded to this expression, where equals to here, and then fill inside the values and see whether it equals to 0 or not. 2. Referring to task task number 2, different angle. If we change the material of block and plane from wood to steel, do we expect higher angle before the blocks start to move? Okay, earlier we have wood and steel 0.42. Wood and steel, where's wood and steel? Wood on wood. Oh, okay. If we change the material of the block and plane from wood to steel, okay. Earlier we have wood to wood, okay. Wood to wood is here. Okay, I'll highlight it. Okay, earlier we have the wood to the wood equals to 0.42. Now we want to change steel to steel, 0.74. Change the value into 0.74 and then see whether the angle will change or not. Will it still be the same as task 2 or not? Okay, find some spaces there. I forgot to put a box for the calculation. Okay, we'll go to the next one. This will be the conclusion. Referring to task 1, write the conclusion. Okay, conclusion will depend on the objective. Okay, conclusion number 1 are referring to objective number 1. Task 1. We want to find what is the critical value of coefficient of static friction before the block is moving. So the conclusion will be coefficient of static friction is a factor moving the block. And then for our case, For the case above, the critical value coefficient of static friction when the block is moving is what value? 0.576, let's say. Okay, how about for the conclusion, task number 2? You can copy quite the same. The angle am I spell correctly the angle? The theta, the angle, sorry. Angle is a factor moving the block. For the case above, the critical value angle of the plane when the block is moving equals to how much? Maybe 22.8. Okay. Okay. Complete the report. You can discuss among your group members. Complete the report and then submit individually into the eCampus. For this problem, you're going to produce a video explaining to children how you conduct this experiment. Everybody going to commit at least 1 minute of the presentation, starting from the introduction until the conclusion. So the video length will be between 5 to 7 minutes. If any question, you can email to me or I'll be in the Google Meet waiting for you. Okay, bye.